Google is transforming the landscape of computing with its new quantum chip called Willow. This innovation indicates a new era of speed and efficiency, surpassing the capabilities of even the most advanced supercomputers. But do you think this chip will change the world? Join us as we unveil this Google innovation that will take the world to a new era. So, Google has recently unveiled an innovative quantum chip that it claims can solve a complex problem in just 5 minutes. In stark contrast, the fastest supercomputers available today would take an unfathomable 10 septillion years to complete the same task. This remarkable advancement highlights the potential of quantum computing, a field that aims to harness the principles of particle physics to create computing systems with unprecedented power and efficiency. The newly developed quantum chip, named Willow, is touted by Google as a significant leap forward in the quest for practical quantum computing. It is said to incorporate critical breakthroughs that could pave the way for the development of large-scale quantum computers capable of tackling a variety of complex problems that are currently beyond the reach of classical computing systems. These breakthroughs may include advancements in qubit stability, error correction, and quantum gate operations, all of which are essential for building a functional and reliable quantum computer. However, despite the excitement surrounding Willow, experts in the field urge caution. They emphasize that while the chip represents a noteworthy step in quantum technology, it is still primarily an experimental device. The journey toward realizing a fully operational quantum computer that can effectively address a range of real-world challenges is expected to be a lengthy one, requiring significant investment both in terms of time and financial resources. Estimates suggest that it may take several more years and billions of dollars in research and development before we see a quantum computer that can be applied to practical problems outside of controlled laboratory environments. To understand why these experts have urged caution, it's necessary that we examine how this quantum computer operates. Quantum computers operate on principles that are fundamentally distinct from those governing conventional devices such as smartphones and laptops. Unlike traditional computers, which process information in binary form using bits that represent either a 0 or a 1, quantum computers utilize quantum bits or qubits. Qubits can exist in multiple states simultaneously due to a phenomenon known as superposition. This allows quantum computers to perform many calculations at once, significantly accelerating problem-solving capabilities for certain types of complex tasks. The principles of quantum mechanics, which describe the peculiar behaviors of subatomic particles, enable quantum computers to tackle problems that are currently intractable for classical computers. For instance, they can efficiently factor large numbers, simulate molecular interactions, and optimize complex systems, which could lead to breakthroughs in various fields, including cryptography, materials science, and the development of new pharmaceuticals. The potential for quantum computing to revolutionize industries is a source of great optimism among researchers and technologists, as it may lead to the discovery of novel substances and treatments that could save lives and improve health outcomes. However, alongside this optimism, there are significant concerns regarding the potential misuse of quantum computing technology. One of the most pressing issues is the threat it poses to current encryption methods that safeguard sensitive information. Many encryption algorithms, which are foundational to online security and privacy, rely on the computational difficulty of certain mathematical problems. Quantum computers, with their superior processing power, could potentially break these encryption methods, rendering sensitive data vulnerable to unauthorized access and cyber attacks. In light of these concerns, major technology companies are taking proactive measures to enhance their security protocols. For instance, Apple announced a few months ago that it is enhancing the encryption of iMessage communications to ensure it is quantum-proof. This initiative aims to protect user data from potential decryption by advanced future quantum computers, thereby reinforcing the security of personal communications. By investing in quantum-resistant encryption techniques, Apple is not only addressing immediate security concerns but also preparing for a future where quantum computing could pose significant risks to data integrity and privacy. As the field of quantum computing continues to evolve, it is crucial for both researchers and industry leaders to balance the pursuit of innovation with the responsibility of safeguarding sensitive information. The development of robust security measures will be essential in ensuring that the benefits of quantum computing can be realized without compromising the privacy and security of individuals and organizations alike. This is exactly where Willow comes in. Let's check out how Willow can handle these challenges. Hartmut Neven, the head of Google's quantum AI laboratory, has taken on the role of what he describes as the chief optimist for the ambitious project known as Willow. In a recent interview with the BBC, Neven expressed his enthusiasm for the potential of quantum computing, emphasizing that it is poised to serve a variety of practical applications in the future. However, he chose to keep specific details about these applications under wraps for the time being, hinting at the exciting possibilities that lie ahead. Nevin also provided insight into the timeline for the development of quantum computing technology, indicating that a chip capable of supporting commercial applications is not anticipated to be ready until the end of the decade. This timeline reflects the complex and challenging nature of quantum computing, which requires significant advancements in both hardware and software. In the first stages, the applications of Willow are expected to concentrate on simulating systems where quantum effects are particularly pronounced. Nevin highlighted several key areas where quantum computing could make a substantial impact. For instance, he mentioned the design of nuclear fusion reactors, a field that could benefit from the ability to model complex interactions at a quantum level. Additionally, he pointed to the understanding of substance mechanisms and pharmaceutical development as critical areas where quantum simulations could lead to breakthroughs in medical science. Furthermore, Nevin noted the potential for quantum computing to enhance automotive battery technology, which is increasingly important in the context of electric vehicles and sustainable energy solutions. These examples illustrate the broad range of industries that could be transformed by advancements in quantum computing, underscoring Nevin's optimistic outlook on the future of Willow and its applications. As the project progresses, it will be fascinating to see how these theoretical applications evolve into tangible solutions that address some of the world's most pressing challenges. Now stay tuned as we explore what this quantum computing is all about. Companies globally are engaged in a competitive effort to develop a groundbreaking new generation of computers. Mr. Nevin informed the BBC that Willow's capabilities signify it as the best quantum processor constructed to date. However, Professor Alan Woodward, a computing specialist at Surrey University, asserts that while quantum computers will outperform current classical computers in various tasks, they will not serve as replacements. He cautions against exaggerating the significance of Willow's success based on a singular test. He remarked to the BBC that people should exercise caution and carefulness while making comparisons that are not equivalent. Google selected a problem specifically designed as a performance benchmark that was tailor-made for a quantum computer, which does not illustrate a universal acceleration when compared with classical computers. Nevertheless, he acknowledged that Willow does signify considerable advancement, particularly in the area of error correction. In basic terms, the utility of a quantum computer increases with the number of qubits it possesses. A significant challenge associated with quantum technology is its susceptibility to errors, a tendency that has historically intensified with an increase in the number of qubits on a chip. However, researchers at Google have reportedly addressed this issue by successfully engineering and programming a new chip that demonstrates a reduction in error rates across the entire system as the qubit count rises. This achievement is regarded as a pivotal breakthrough in the field, which has been striving to overcome this challenge for nearly 3 decades. According to Nevin, he likened the advancement to the safety improvements seen in aircraft design, stating that while a single-engine plane is functional, having 2 engines enhances safety, and 4 engines provide even greater reliability. Errors remain a formidable barrier to the advancement of more powerful quantum computers, and Professor Woodward expressed that the development will encourage everyone striving to build a practical quantum computer. Nevertheless, Google acknowledges that for quantum computers to be practically useful, the error rates must be significantly lower than those currently exhibited by the Willow chip. If you've made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now.